Allô, bonjour et bienvenue encore à notre classe. On part comme toujours dans cette classe quatrième de la relation entre la musique électronique dans le XXe siècle et aussi la philosophie dans la France. Comme ça, nous allons parler aujourd'hui bien sûr de Monsieur Deleuze et son influence sur la musique. Et à ce point-ci, c'est quand typiquement les Américains maintenant ils me disent don't you mean Deleuze? Oh non 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 non, mon ami, nous ne sommes pas à Toulouse, on parle de Deleuze et en particulier on parle de la rhizome. Et le rhizome, c'est un truc dont mais c'est quoi ça? Rhizome, no such object. Ah, bien sûr, rhizome. Le faute c'est le mien. On ne parle pas de rhizome, on parle de rainbow. I realize, having finished that bit, that not only is it not that funny, but it also doesn't really make sense. But yes, we're not talking about whatever I was pretending to talk about before, but we're talking today about rainbow. And this is something really interesting that has come out in the last couple of years. It's a sort of extension to Max, an add-on to Max, that lets us make DSP in Max, so sort of synthesizers like we looked at last week, or things that play back sound like we looked at the week before, and take those pieces and export them, and then run those pieces in other contexts, be it a web browser, an audio plugin, or a few other possible destinations. What did I want to say about this? I guess nothing. I guess we should just dive right in. But before we go too deep into talking about Rainbow, we should take a quick step back and just talk briefly about subpatchers, because Rainbow is a subpatcher context, and we haven't actually looked formally at subpatchers yet. So something that may come up in the course of your work, maybe you're doing something like, I don't know, you've got a source of noise, say, and you've got an oscillator, say, and you'd like to crossfade between the two, right? Why not? So you make something like this. You say, okay, I'm going to multiply each one by some value, and I'm going to have another control here. Maybe let's make a slider and set the range of this slider to be in the range 0 to 1. And then we're going to use this to fade between these two audio signals by first constructing an audio signal that's just a ramp. So I make a live scope here, and now as I drag the slider around after I turn on audio processing, sorry, there's another patch here. So there's a signal. I can use this to make a signal. We've seen this before. Last class we looked at smoothing out the output of a slider using a line object. And, I can multiply one side of this equation by the line, and I can use a exclamation mark minus tilde object, one of the harder objects to just sort of scan and read, but all this does is take this signal and subtract one from it. Subtract it from one, rather. So if you look at the output of these two signals, you'll see that one is always sort of the mirror of the other. Not this signal, but this signal. So the output of this line and the output of this exclamation minus one, they're opposites, right? One is one. This is just the smooth output. This is one minus that smooth output, so they're always opposite. And I can use these together to fade between two different sounds. So if I delete this and bring this other multiply up here, you'll hear this is some kind of crossfade that fades between two outputs. And if I make live.gain and an easy DAC, we can sort of hear what's going on here. I have done something wrong, and the thing that I've done wrong is I've connected them both to the same output, and that is just not right at all. There we go. So now you can actually hear fading, hopefully, between these two things. So what we might say that this whole part of the patch, these multipliers, this minus here, and this line, and maybe even this smoother here, we might say this is kind of cool, but like all this is doing really is a crossfade. I want to take this and kind of hide this complexity away and treat it as if it were its own object. We can do that through encapsulation or taking this and making it into a subpatcher. So I could just make a new object box and type the word patcher. This will create a subpatch, and basically everything that happens inside this subpatcher or this patcher object is exposed to the top level patcher through an interface that we define in this subpatch here. So if I close that window and lock this patch, I can then double click on this patcher object to reveal the contents that are in there. And having done that, I can edit this just like a regular patch. I can put in a comment that says, hi, this is my subpatch. And then if you open the patcher again, there's what we put in there. You can also create inlets and outlets. So if I make an object called inlet, we get an inlet. If I make an object called outlet, I get an outlet. And these, inlet and outlet, as you can see back up here in the main patcher window, defining an inlet and outlet like this has created inlets and outlets here on the actual patcher. So now I can actually define some new behavior. Maybe I want to add 10 to whatever comes through here. And now this subpatcher will have that behavior where it adds 10 to whatever comes through it. This is one way to make a subpatcher. You can also just select all the objects that you would like to encapsulate into a subpatcher and go to Edit, Encapsulate, or else push Shift Command E on a Mac, and it will create a little subpatcher for you like this. And you can even give it a name. P, this is just shorthand for patcher in the same way that cell is shorthand for select, S is shorthand for send, T is shorthand for trigger. A few Max objects have this behavior. And now this is doing that same behavior. So I bring this fader back up. All that behavior that we made before has been encapsulated into this subpatcher. And this obviously is kind of useful for reusability and other things like this. These subpatchers, however, they only sort of exist in the parent. I'm going to go ahead and save this quickly, actually. Let's save this in a new folder. By the way, I hope for those of you who are in the actual in-person class, hope you're enjoying your snow day. For those of you who are not in the greater New York area at the moment, or I guess in the Northeast coast or whatever, we had a crazy snowstorm and people weren't able to go to class because, I mean, it wasn't even that crazy, but you know. Anyway, I'm not here to talk about snow. We're here to talk about computer music. So anyway, making this new folder, and I only bring this up because in previous lectures we've had internet and in-person patches saved separately, but it's going to be all internet today because I'm recording this video in lieu of actually going in and teaching. Anyway, so let's just save this, patcher1, class 4, and the thing I wanted to say about this, yeah, I remember. So these are embedded in the patch, so if I copy it, I mean, it's actually kind of nice that, you know, now we have this other crossfader here, and I can use this, all that behavior that I chucked into that subpatcher, it's now available for me in other places in the patch, so that if I now want to use the same logic to fade between two different sine tones, I can do that. The only thing is that having done this, there's two things that might concern you. Number one is if I make a change to one of these, so say, I don't know, I thought 40 millisecond ramp time, that's a little bit too short. Maybe I want a 50 millisecond ramp time. Well, if I go into this other subpatch, you'll see that it has not updated to reflect that change. They're not actually linked together. Each one has its own objects, its own everything. And so there's that issue, potentially. The other potential issue is that I can't use this in any other patch. If I just make another patch and I say p crossfade, you'll see that it's empty. Max doesn't have any awareness of this patch outside of the patch that this subpatch outside of the patch that contains it. We can get around this, or rather there's another kind of mechanism in Max that addresses this called abstractions. Abstractions basically let you load another patch as if it were an object. It's a cool way to kind of make reusable pieces out of the stuff that you build in Max. So I could take this whole thing here, and if I just copy everything, so I'm going to copy, make a brand new patch, paste it in. So this is a totally new patch, its own kind of root top level patch with all these inlets and outlets and everything. And if I save this as, let's call this crossfade, well, we can just call it crossfade, why not? Now the crossfade abstraction is available to other patches. In order for other patches to be able to find them, they need to be somewhere that's available, either in the Max path, which we're not going to talk about today, but it's worth reviewing, especially if you can find the reference, how to configure the Max path to make files available in from one patch in another patch. But also if they're in the same folder, Max will always be able to find them. So if I save another patch here, because this patch, this PO2CO4, is in the same folder as that crossfade abstraction we just saved, I can now actually make a new object here just called crossfade. And it even shows up in the autocomplete, which is kind of handy. And if I double click on this, you'll see that this is actually that patch that we made before. And I can take this and I can make, so everything that we've already done here, these crossfades are using the using that subpatch, that crossfade subpatch that we made a second ago. But I can do the same thing as this. Sorry, just rearranging these pieces. I can do the same thing as this using this actual crossfade abstraction. So if I call this crossfade now, has the same behavior, but it's using the abstraction and not an embedded subpatcher. And in fact, what's kind of cool about that is if I duplicate all this and then make another copy, if I make a change to this abstraction, I'm actually changing the file on disk. And part of the Max tries to keep you from accidentally overwriting and destroying your old work by disabling editing until you come down to the bottom. If I open this abstraction from this main patcher, it opens in kind of a safety mode, and I have to actually come down to the bottom left here, and where the edit button usually is, click this button that says modify read only. Having done that, now I can actually edit this file as it appears on disk. And if I come in here and change this back to say 40 and save it, I'll see that not only is that change reflected here, now it's 40 instead of 50 in this instance of the abstraction, but also if I come into this one, it too has been updated to reflect that change. So abstractions are a really cool way, a really useful way to make reusable pieces of logic that you can use in other parts of your throughout your work. And in fact, you may find that you're making a bunch of abstractions and building up your own library of kind of stuff that you can use through the course of your work. So having talked about subpatchers, and remember, you can always open a subpatcher by locking and double clicking on it. Same goes for an abstraction, just lock and double click and you can look at the contents. Having made abstractions and subpatchers, we're ready to talk a little bit about RNBO. Okay, so bonus content that I'm actually going to move to the front of this video when I do the little mandatory edit that I have to do. I wanted to show some examples of stuff built in the browser using RNBO. There are some cool ones out there. The first one, if you go to cycling74.com/products/RNBO and look at what the product page that describes kind of what it can do, there's actually a playable demo in the browser. This is a Max patch exported from RNBO. Well, it's a RNBO patch exported from Max that runs in the browser. And if you come up to the URL here and you add after here, you go $rem equals blob, you can look at an unused version or another experiment that we built that didn't end up getting used. But this is actually, personally, one of my favorite things that I've seen made with Rainbow. So again, Max patch exported with Rainbow. Sorry, Rainbow patch exported with Max, connected to some web audio, or rather connected to a web audio context so that it can be played in the browser. There's another thing that's kind of come to my attention recently that's even cooler than this, which is, if I come to, sorry, let's see, class 4 README. Yeah, this is something that has popped up recently, is a kind of like, I guess, a collection of kind of these virtual cards. It has, I think there's like a crypto or what is it called? Not crypto, but built on crypto, an NFT component to it or something. But these sort of planetoid things, I don't really, so I think they're like collectible digital trading cards where each one also has like a unique sonic signature attached to it. Here's one. And if I go to the next one, we can hear some other sound. And we can try another one. And each one of these is, I think, using the same Rainbow patch, exported with different parameters set for them. It's one of the more like ambitious, fleshed out, fully realized, and good sounding Rainbow examples that I've seen. The last thing, I would be remiss if I didn't point out learning synths. Actually a great resource to kind of build on what we were talking about in the last class. This is using Rainbow patch exported running in the browser to kind of demonstrate how synthesizers work. And you can kind of come in here actually, and if you go down to the playground, you can see how the synthesizer is working. And get a feel for modulation, oscillators, how all this stuff can kind of come together. All stuff we talked about last week, but sort of amazingly built on top of a synthesizer that was built in Rainbow, exported, running in the browser. So those are some cool examples of using Rainbow. And now we're going to dive in and talk a bit about how to actually work with it in Max, how to plug the stuff into the browser and make something cool with it. So I'm going to make a new patcher here, and I'm going to make an object called rainbow tilde. The R and the N kind of blend together, but this is rainbow, or RNBO. And inside of this object, we're actually kind of working, so it's similar to a subpatcher, this rainbow patcher. I mean, it is a subpatcher. The only subtle difference is that we're actually not working in Max anymore. We're working in Rainbow. And Rainbow's been designed to feel just like Max. The whole kind of selling point is that you can make patches that are more or less one-to-one copies of the equivalent thing in Max, but then you're not trapped in Max. You can take your work, export code, or export some other standalone targets, and use that in other contexts. And we'll come back to this a few times because we'll see how to bring this to other targets. But today I want to talk specifically about how to bring all this stuff to the browser, to the web. So in that spirit, the thing to kind of remember about Rainbow is that so Max is kind of like always running. If I make a object that makes noise and I connect it to an object that, goes to the audio output, it'll just work. Rainbow's a bit different. Every time you make an object, you'll notice this little kind of progress bar at the bottom of the patch, and you'll see the rainbow object too has a little progress bar overlay. And that's because as we're making changes to this rainbow patch, Rainbow itself is updating. Rainbow itself is taking this patch and building a description of that patch that is just code. It's generating pure C++ code that is a representation of what's happening in that patch. And then it's compiling it and kind of sticking it back into Max. So this is the thing that enables Rainbow to work, is that Max is kind of hosting a little program that you're building and rebuilding every time you change your Rainbow patch. And because of that, it means that that program is kind of always ready to go. It's sort of always ready to be taken and plugged into another context, because from the start, Max is just sort of hosting that program. So with that in mind, we can look at how to actually get stuff in and out of Rainbow. In general, there are 3 mechanisms that we can use to get data in and out of Rainbow. There are params, there is Midi, and there are messages, inlet and outlet. So these are the 3 ways to get data in and out of Rainbow. And let's start by just looking at and I guess audio is another way. Audio signals in and out of Rainbow is the other way to get data in and out of Rainbow. So let me think. Let's look first at just getting audio out of Rainbow. So here in my Rainbow patch, just like in Max, I can make a cycle object to make an LFO. And then I can't actually type outlet. There's no such thing in Rainbow, but there's a close equivalent called out tilde. And out tilde is basically the same as outlet. The difference is that there is an audio rate and message rate version. So there's also out. So in addition to out tilde, there's also out. Rainbow's not letting me make one because you can only have one for a given outlet. Can only be either audio or message. It can't be both. But there is an object called out, and if I make one called out2, it should get created normally. So that's one difference. The other difference is that you actually have to provide an index for that particular outlet, which has advantages and disadvantages. I guess one big advantage is we can have another one of these, and you could send audio to this outlet or to this outlet if you wanted to. You're not limited. I think that's true. Is Rainbow going to tell me it's complaining, or is it going to complain if I delete this and undo delete it? No, it's fine. So you could send out audio to either one of these, and it's almost like having a send and receive built into your patch. But anyway, the point is use out tilde to get audio out of Rainbow and give it an index so it knows whether it should be outlet 1, 2, 3, etc. Back out of my main patch, now I can make a, let's make a live.scope, and I can look at what's coming out of my Rainbow patch. And indeed, there's an LFO coming out. I can change the rate of this LFO using a param. And params kind of define sort of properties, numerical properties on a Rainbow patcher. So I can, and param, by the way, doesn't exist in Max. It's a Rainbow only thing. So this is one of those kind of subtle differences between the two. But again, it comes back to Rainbow being designed as, always designed to be run in other applications. So we're defining like an interface between the host application, in this case Max, and whatever's going to be running your code. So I can do param freak, and then maybe set this to like, give it a minimum at min, 10, at max 100. That's crazy. Maybe like, well, I don't know why it's crazy, but maybe 1 to 100. And then if I connect this to my cycle, after everything recompiles, now this Rainbow object recognizes freak as a parameter. And Max interprets that by binding attributes to those parameters, so I can make an adder UI. Now we've seen in some other classes, and I can actually select freak down here. So at the bottom of all of these attributes, there's another one named freak, because that's the name of our parameter over here. And if I select that, now I can actually, now I can actually change the frequency of this LFO or this oscillator that I've made using this attached parameter. Okay. So we talked about, we talked about parameters, we talked about audio. Last thing that we should probably talk about before we get too much further is Midi. So Midi is actually really interesting with respect to Rainbow because Midi also defines kind of the basis for an easy version of polyphony. I'll show you what that means in a second. But first, let's get some Midi into this Rainbow patcher. So we can do that simply by defining any one of the Midi. Let's go ahead and save this. Yeah, so we can do that by defining any one of the sort of Midi family of objects. So that's anything like note in, control in, Midi in, all of these, any one of these objects, if you put it in your Rainbow patch, it will define the Rainbow patch as having a Midi interface. So if I do note in, now this Rainbow patch is configured to accept Midi, and another inlet has appeared here on the Rainbow object that is the Midi inlet. With this note in object, now I can build the kind of typical behavior. So let's say we wanted to make a synthesizer. Now we can make a synthesizer using Midi in here. So I could maybe get rid of this frequency, and instead of using that, controlling that with a parameter, I could do the typical kind of stuff that we would do, M to F, to turn that Midi pitch into a frequency. Pitch is coming out of that left outlet, or this left outlet here. I can make an ADSR for my attack, decay, sustain, release. And I'll just give this some kind of boring typical values, maybe like 5, 20, 0.4, 200. Divide the velocity by 127 so that it's in the range, instead of being in the range 0 to 127, it's in the range of 0 to 1. And then multiply this ADSR by this cycle. It's just a quick and dirty kind of synthesizer. And now, if I go back out into my main patch here, and I do K-slider, we've seen this kind of thing before, so hopefully this doesn't look too unfamiliar. But I wish I hadn't done that because I want there to be a clean sequence of patches. I wish I'd saved and made a new copy, but it's okay. I think it'll all make sense in the end. So what I'm going to do, this thing that we've seen before, where we take the pitch and velocity coming out of this K-slider, we pack them together. There is one kind of difference with what you have to do in order to get Midi into Rainbow. It doesn't accept, so we've seen before some objects that accept note on, note off pairs, but Rainbow tilde actually, in this Midi inlet, it wants specifically the actual bytes of Midi data that we're generating. So, you know, if I take one of these notes and I press it, we'll see a pitch velocity pair like this, 5985. But this list thing, the thing you have to understand about Midi is it's a low-level protocol. It runs over a serial connection, and it's just a stream of numbers. And it's kind of like low-levelness, and its simplicity is why, you know, instruments that people are making today can interface with instruments made in like 1970 because the protocol is very simple and very low level. And that's the input that Rainbow is expecting here. There's an object in Max called Midi format. This is the little dance you have to do in order to get Midi data into Max. It all hinges on this Midi format object that can take different kinds of Midi inputs. So Midi note events, Midi control change events, program change events, aftertouch, pitch bend, that kind of thing. And what you'll see is if I make a print object here and I hit one of these notes, if I look in the console, you'll see that it prints out, well, in addition to all this other garbage that it's warning me about, you'll see here these 3 bytes. These are all numbers between 0 and 255 inclusive. And this is the actual sequence of numbers that are getting sent out in the Midi format in the Midi protocol check it out if you kind of want to go a bit deeper into what's going on there. But 144 is sort of a code corresponding to a note on event. And then we have the payload associated with that event, these 2 bytes here, in this case, pitch and velocity. So this is just formatting the numbers coming out of the case slider in the Midi format so they can be understood by objects like Rainbow Tilde that's expecting that raw Midi stream. But now, if I hit one of these keys, we should see some actual data here. Of course, that note on, it's a stuck note now, so I got to send this a 590, a note off event to clear that. But we can also make a make note, say 127, 500, to turn these into notes that we can listen to. And if I go like this, and then take the pitch and velocity coming out of make notes, pack them together into a list. Now, we can even hook up a live.gain, and we should be able to hear the output of this thing as a kind of synthesizer. So I'm going to save this and then save a copy. The first thing you'll notice is that it sounds a little bit funky. It sounds a little bit funky because when I press, so it sounds a little bit funky. It kind of sounds like some notes are being repeated in a weird way, or the pitch is jumping back to what it... It actually sounds kind of cool to my ear, but basically each note is jumping back to kind of where it was before a second ago. That's because this Rainbow Tilde only has one voice. So even when I hit 2 different keys, it's not able to make sound corresponding to, it's not able to say add together one cycle corresponding to the frequency of one key and another oscillator corresponding to the frequency of another key. It's only got one oscillator. So if I push 2 different keys, it's not able to keep up somehow. It can only represent one at a time. In Max, there's a few ways around this, including voice allocators, the polytilde object, just duplicating your oscillators and using... Anyway, one thing that Rainbow does that's really nice is, especially for kind of MIDI-oriented instruments like this, where you have a MIDI stream coming in and then audio going out, there's very, very easy polyphony. And Rainbow can do all the voice management for you. So I can even go to this Rainbow Tilde object and do nothing more complicated than @polyphony, say 10. And what this will do is it will actually duplicate this basic patcher 10 times, although you don't have to worry about that. But it will duplicate this patcher 10 times. And now... you should be able to hear multiple notes playing at the same time. And that's because Rainbow is doing all the kind of complicated work of making sure that note ons go to the right place, note offs go to the right place, and all the oscillators and their envelopes are updating when they should be. So here's the, very basics, very basic. This is like a little synthesizer that we've built already in Rainbow. And now what I want to show you how to do is to connect this up to the browser and use the synthesizer to drive some kind of processing in a web application. So for that, I'm going to first recommend that you go ahead and pull the latest version of the repository if you haven't already. Because in our repository, specifically in the class 4 folder, there's this folder called www.start. And this I want you to use as sort of a template for building a web application. And we'll take a look at what this offers us. But I wouldn't recommend duplicating it right here in the repository folder. I'm going to make a new folder somewhere. I've got one here called Sound Studio. And I'm just going to duplicate this folder, www.start. So I'm copying www.start from, so if you go, just to make sure it's clear, in the root of the repository, make sure you pull the latest, go into class 4, find www.start, and just copy this somewhere in your machine. And you can do this anytime you want to kind of experiment with mixing rainbow and P5 in this case. We're going to be using kind of to do the drawing. So I'm going to come into www. It's way harder to say www start than I thought it would be, but here we are. I'm going to just open this folder in my text editor, and we can sort of take a look at what's in there as soon as it loads. So first of all, there is this kind of default web page that's doing nothing more complicated than loading the P5 library. So that's happening right here on this line. And we're also loading a small folder of a small file, I should say, of some helper scripts, some helper functions rather, some JavaScript functions that make working with Rainbow a little bit easier. We'll get to that in a second. And then finally, there's this folder export. And this is where we're going to put our Rainbow exports. And we'll talk about that in a second. Before we get to that, there's something that I should talk about, which is if we take a look at this HTML file and just open it, it'll open in Firefox, or open in whatever web browser you happen to have set as your default, but it's opening as a file URL. Just hold that in your mind for a second, and I will show you why we had to go through the business of installing Node and why I sent that email about how we're going to use the command line a little bit. It'll all become clear in a second. But first, let's jump back to Max, and let's actually export this file. So I'm going to grab this. So the way to export Rainbow is you first go into your Rainbow subpatcher, and then on the right side of the patcher, you'll see this icon here that when you hover over it, it says Show Export Sidebar. I'm going to click on that, and this export sidebar lets us configure Rainbow exports. And in this case, we're interested in this one here, the web export. So I'm going to click on that, double click on it, I guess, and this will let us configure that export. The important ones here for us are the output directory, where it's going to go, and the file name. The default is patch.export.json, but if we come back to the top level parent patcher, and we give our Rainbow patch a title, so if I change the title of this Rainbow patch, if I go at title my synth, then not only does the name of the synth, or name of the window, I should say, change here to be my synth, but if we go back to that export sidebar, the file name will default to my synth. Kind of handy sometimes. I'm going to hit this choose button for the output directory, and I'm going to put this in where I just made that new folder. So I'm going to go to Documents, I'm going to go to Documents, Sound Studio, www start export. I'm going to put that exported file in here. And after I push open, you'll see the path here in the output directory. And if I hit now this button in the bottom right that says export to selected target, the export process will start. Now this actually takes your patch, turns it into C++ code, sends it to the Rainbow server, and the Rainbow server converts this into WASM, or WebAssembly. And what that is a kind of low-level language that the browser is going to use to run the audio code that you have on a high-priority thread. And this is the only way to get audio to work in the browser that, number one, is more efficient than vanilla JavaScript, and number two, doesn't use the same thread as all the other JavaScript happening on your web page, whatever web app you're trying to build. It keeps the audio processing and your kind of application logic on separate threads so that if something heavyweight and complicated is happening in your application, it doesn't actually interfere with the audio processing happening on your audio thread, which would be a problem because as soon as you interfere with what's happening on the audio thread, the demands on the audio thread are very high. It's got to, every single second, it's got to provide 44,100 samples or so. And so if you interrupt that thread, you're going to hear clicks, discontinuities, distortions. So it's best just to give that thread that thread, you just got to get out of its way, okay? That thread, whatever it wants to do, you let it do. No question. You let it do it. No questions asked. Anyway, the export has completed. I can hit this open button in the bottom corner, and you'll see these files here. The important one is this mysynth.export.json. And if I come back to the text editor, I can actually look at it, and you can see what RNBO has exported. It's exported this little JSON file that has a description. We're not going to dwell too much on all this, but it has a description of kind of what our patch is all about, including the parameters in the patch. And then here in source, we have this code here, and this big block of code is actually the WASM, the WebAssembly code that the browser is going to run when we run our patch. So what we can do now is go back to, or rather, what we can do now is make sure that this code actually gets loaded. And now it's time for us to write our actual web application. So in index.html, you know what? I should fix this before I actually upload the, I'll fix this before I upload the, well, after I upload this video, I guess, I'll fix this. So you probably won't see it looking like this. But I mentioned here that this is where we're importing the P5 script. This is where we're importing those RNBO helper functions that I mentioned. And down here is where we're going to import the script that is our actual application. So I'm just going to rename this to sketch.js. And this is going to be, we'll write this file now. So I'm going to go into JS and make a new file called sketch.js. And now we can write our big, beautiful application. And let's just make, because P5 is in here, we can just make a generic kind of P5 sketch. I can do setup. Oh, that is not what I wanted. A security policy violation event. Definitely not that. I meant to type setup. I have both VS Code autocomplete and GitHub Copilot going at the same time. Sometimes they both get really excited about auto-completing my text, and there can be some contention. And now I'm all kind of messed up too, because this should say function setup and function draw. And, oh, jeez. What I'm going to do now is in my, let's just make sure we can see something. So in my setup, I'll do create canvas 600, 600. And then in draw, we'll just do, well, you know what? Let's actually do color mode HSB 255. And then in draw, we'll do background. I don't know, what's a nice hue? Maybe like 10. Middle saturation, 80, 255. And then I should be able to reload this page. And there it is. I didn't know it was going to be this salmon color, but there it is. Here's our page. Did I do what yeah, hue 10. Okay, yeah, it makes sense. Cool. So we've loaded P5 into this page. How do we get RNBO involved? Well, what we can do now is actually load our RNBO device. There's a helper function in here that makes it a little bit more streamlined, as you can kind of see. So RNBO, what it does when you load your RNBO patch, it gives you back a web audio node, and then you can take that node and connect it to other web audio nodes, and in particular to the destination. There's a few moving parts here, and it's kind of more complicated than I want to get into in the context of this class. So I've made a wrapper function called create RNBO device that simplifies some of this for us, but it is worth kind of going into this file and looking at this function, kind of walking through the parts and making sure you understand sort of what each piece is doing. But in any case, the long and the short of it is I'm going to write another function here called load RNBO. And this is going to do nothing more complicated than call this function, create RNBO device. And it's going to call create, yeah, this is good, create RNBO device. And it needs the path to this mysynth.export. So I'm going to do create RNBO device, mysynth.export.json. Now, this create rainbow device function, there's two important things to know about it. One is that it doesn't return one variable, but rather an array. It returns both the device and the actual audio context that it creates. Number two, it's an asynchronous function. So we have to do a little bit of, we get to learn a couple of JavaScript tricks here. Is this too small? It's probably too small. It might be a little bit better. So I'm going to make two variables here, one to store the device and one to store the context. And now what we can actually do that's kind of neat is like we can do this device context equals, and this is a JavaScript trick called destructuring assignment. And what we're actually doing is saying, okay, I know that the result of this function is going to be an array of two values, and rather than having to take that value, put it into an array, and then assign to my two variables, device and context, from the first and second element of that array, I'm just going to do it all in one line like this by assigning from the output of this function to my two variables in an array. Take a look at destructuring assignments to kind of see what that all looks like. Oh, and the other thing that we need to know about this function, like I said, is it's asynchronous. There's some calls here to like fetch the rainbow patch and a couple of things like that mean that this function doesn't actually return right away. It returns eventually when it has a result. And in order to actually get a real value out of it, instead of just kind of this abstract object called a promise that will ultimately be the result that we want it to be maybe one day, we can use this keyword await. Now, the only thing is VS Code is helpfully going to tell us that we can't use await outside of an asynchronous function. So we'll just make our own function asynchronous. And then after this, we'll call load rainbow. Now, this should load our rainbow device. And when it's done, we can do console.log rainbow device loaded. Now, if I reload the page, everything looks fine. But if I check the console, which you can do by going to Tools, Browser Tools, Web Developer Tools in Firefox, there's an equivalent kind of developer menu in Chrome that will show you the same thing. Also Safari, all browsers kind of have these developer tools. But I'm going to open up these tools and, oh my Lord, I don't know why all that stuff popped up, but if I come down here to the bottom down here, we'll see a few kind of errors. The first error is this, and it's kind of cryptic. It says cross-origin request blocked. The same origin policy disallows reading the remote resource at and the path to our JSON file. So the kind of issue here is the browser is trying to protect us from us, not the developer of this application, but protect us, the user of the application, from something potentially nefarious. Because this WASM code that comes from the export of our rainbow patch is running in this special kind of thread, it has to fulfill certain security requirements. In particular, it has to be fetched from the same origin that was used to access this file in the first place. So what that means is, long story short, we actually can't use a file URL like this when we access this page. And because of that, we can't open this page by just double clicking on it. So it's kind of one of the first, I guess, sort of stumbling blocks when you get into the space of trying to build web apps using Rainbow, is you can't just double click on the file like this. You have to actually run your own web server and then access the page that way. Luckily, that's not so difficult, especially if you have Node installed. I'm just going to open up my terminal now. So this is, through the magic of editing, I've cut out a small piece of video where I might have accidentally doxed myself by revealing some, I think were public keys, might have been private keys. So better safe than sorry, I suppose. I'm just going to now, so the whole thing has made me lose my train of thought a bit. But I wanted to show you the very basics of using terminal. We don't need much. Really, ls and cd will be everything we need. I could do cd NYU, and that takes me to the NYU directory. I can do ls, and that shows me all the folders in that directory. I can do cd teachable machine, and now I'm in that teachable machine directory. cd space ... will take me back up one level. If I want to go to a particular directory, I'll show you a trick that works on Mac OS. I don't know if this works on Windows, but I can do cd and then go to the folder here, and then actually just grab, this is the folder I want to go to, the www-start folder that I copied. And if I just drop that here in terminal, it will paste the full path in there, which is pretty handy. And if I hit enter, now I'm in that directory. So what we need to do here is actually run our web server. Luckily with Node, that's extremely easy. All we have to do is npx space, make this a bit bigger, npx space http-server. And this will download and install the HTTP server package and then run it. So now, as you can see, I've got a URL here that I can use to view my page. That's 127.0.0.1 on port 8080. That's also 127.0.0.1 is of course localhost. And so I don't have to do anything. I don't have to do anything more complicated than come here, make a new tab, and do something like say localhost : 8080. And now I'm viewing that same page. And if I open up the inspector, I can see, well, I see a different error here, but we'll get to that. The important thing is that we're not seeing that same CORS error as before, which is good. This error, JSON parse, makes me think that it's not actually opening our rainbow file. And if I go to here where it's saying await create rainbow device, and then I gave it the name of the device, but I did not give it the full path to the device. So it's actually in this folder called export. So what I need to do is do not just mysynth export JSON, but export / mysynth export JSON. I save this, come back to my browser, and reload the page. It's not able to find the style sheet or the favicon, but it has loaded the, I can see there's no error related to rainbow, and at the bottom, it indeed says rainbow device loaded. Fantastic, we're making progress. So what I want to do now is actually play some notes, right? When we do something. So to do that, I'm going to make use of two other rainbow helper functions. And again, it's kind of worth going in and taking a look at these just to get a flavor for what rainbow is doing. But you'll see I made here a note on, a note off function that kind of simplify playing a Midi note. And the thing that I want to maybe draw your attention to here is this bit here where we construct the Midi message from its actual bytes. You'll see 144 pitch velocity. And if you remember, that's the same sequence of kind of raw Midi values that were coming out of the Midi format object in Max corresponding to a note on event. So you can see that kind of the rainbow device in the browser is using the what we would expect, the same kind of like Midi serial format. So anyway, all this is doing is taking, moving some bytes around so that we can say, okay, rainbow device, play a certain pitch and a certain velocity starting now. So that gives us some freedom to back up in our sketch. I can make a function mouse pressed and function mouse released. And I'm going to, Copilot is trying to help out and is actually doing partially what I want to do, but not quite there yet. Okay, so now, mouse pressed, I want to start a note on, and mouse released, I want to start a note, or I want to end the note, right? So click the mouse, note plays, release the mouse, note stops. And for now, we can just play a random note. So I'm going to do in mouse pressed, let note equal, and now we can actually use does P5 have a random function? P5, is there a nice random function we can use? Random, returns a random number. We'll do a random number in a range. I'm not a P5 expert. Random min-max. Oh, cool. So maybe we can do random 50, 70. And then we can do, the name of the function is note on. So we'll just do note on, passing as as GitHub Copilot helpfully suggests, the rainbow device, the audio context, the note we want to play, and then we could do velocity 127. I'll do velocity 100, not maximum velocity, but something fairly loud. And then for mouse released, we want to release the note. Of course, it's a little bit tricky because we figured out which note we wanted to play here in the mouse pressed function. But then down here in the mouse released function, we need to send a note off event using that same note, that same pitch. Unfortunately, we don't have access to it anymore because that variable is scoped inside the mouse pressed function. Not a problem. We'll just move it up here. I'll do let note equals 0. And then down here, instead of assigning note to a brand new variable called note, I'll just delete this business here. So now we're assigning not to a variable that's defined only in the scope of this mouse pressed function, but rather to a global variable called note. And now in mouse released, I can actually just simply do note off, device, context, note. And the nice thing about this, you'll notice that the note off function does not need a velocity because the velocity of a note off event is always 0. That might not actually be true, but for us, for now, it is. So with this, we're actually in good shape, and I should be able to reload this page. And as soon as I start tapping the background, should hear some notes. Kind of handy. So one thing that you will, if you don't hear anything, it could be because your audio context hasn't started. Extremely common situation to deal with when you're playing with web audio, because it would be very annoying if as soon as you accessed a web page, that page just started playing some sound at you. Anybody who used the internet in the 90s can attest this was very annoying. The way that all browsers are required to work now, if they follow the web standards, is audio can only be started from an action that the user initiates, which means in the context of a mouse clicked function or a scroll function, actually I don't know if scroll counts, but key presses, mouse events, all that kind of stuff are valid places to start the audio context. Rainbow, the function that I wrote, the kind of like setup rainbow function, tries to install something that will take care of this, but in case it's not working for you, you will see a warning like this: an audio context was prevented from starting automatically. That's me alluding to what I was just talking about with the audio context. Very simply, in your mouse press function, you can just do context.resume. You have to be a little bit careful because remember, this function that loads rainbow is asynchronous. So just because we're in this mouse press function, it doesn't mean that this asynchronous load rainbow function has actually run yet. And so we don't actually know for sure, just because we're in this code down here, if this device and context variable have actually been defined yet. It might be the case that this load rainbow function hasn't finished running. Create rainbow device is waiting for a slow network or something. So it's always possible that down here, context and device might not be defined. So we can just do this: if device, and wrap this in an if statement that just makes sure that the device and audio context are actually defined. So this way, we're not going to run into any issues where context is undefined and we're trying to call resume on it, or device is undefined and we're trying to call some function on that. It should protect us from that. So you may not need to call context resume here, but if you don't hear audio, or even just to be sure, you can go ahead and call it here and everything should be fine. So we've now got our very simple note player in place. Maybe it's a little bit dull though. Let's do some drawing. Let's do something simple here. Maybe something like if mouse is pressed, and these are all these functions: mouse is pressed, random, color mode, create canvas. Obviously, these all come from P5. I'm assuming some P5 knowledge here, but if you're not familiar with P5, just know that in its sort of default configuration, including the P5 script like this, installs a bunch of global functions and properties that make it kind of easy to get up and going with basic drawing in a P5 context. So I'm just doing here if mouse is pressed, and then I'll do fill, and then maybe I'll set the fill color. Tell you what, I'll set the fill color to be a function of the note. So we'll do fill, and at the beginning of this draw function, let's do this. Let h for hue equals map, and map is a P5 function that's basically exactly the same as the max scale function. You start with a value you'd like to scale, give it an input range and an output range, and it will scale it accordingly. So I'll just map notes with the input range of 50 to 70, because that's the range of our random down here, and into an output range, say, 0 to 255. That's perfect, the range of acceptable hues. And then I'll just do fill. I don't like the autocomplete here. Fill H, a saturation of 128, and a lightness of 255. That might be value, not lightness. I don't know. Else, we'll just fill. And then here we'll use a grayscale fill. We'll just do fill white. And then let's just draw a circle, ellipse. We'll use mouse X, mouse Y. 50 and 50 sounds great. But in fact, let's not do 50 and 50. Let's create a radius. Let's do let radius equal 50. And then instead of 50, 50 here, we'll do radius. Cool. So I'm just making it now so there's always kind of a circle being drawn. And I think we'll draw persistent circles, but that's cool. We can leave it that way for now. And it'll follow the mouse and change color when we click. So let's see how that looks. I pushed save by accident. So something just happened to me that may happen to you as well, which is I hit refresh and I didn't see any change on the page. Sometimes the browser will cache the results, and when you load this URL, instead of actually going back to the server and pulling fresh data, it'll just give you what it got last time it checked. You can always get around this by, instead of just doing refresh, or reload rather, refresh. So if I click and hold on, I'm trying to find where this is, because if I hit reload, I'm trying to figure out where, I don't know where, in which menu this is the case, but if you hit Command R, it will reload the page, obviously. And in Firefox, if you hit Command Shift R, it will clear the cache and do a hard reload. There's an equivalent mechanism in Chrome, Safari, whatever you're working with, but just be aware that's something that might happen. Clearing the cache, doing a hard reload is one of the first things I would check if you're not seeing changes show up in your page after you reload. But anyway. Cool, so we've got our little circle. It's making some sounds. That's great, I suppose. But it's hardly an interactive web experience at this point. And the thing that we'd like to try to do, I think, is add a little bit of variety to our sound. Maybe let's try to see if we can create some kind of something in Max that we can change, and then see if we can control that from web audio. So I actually feel like if you're comfortable with maybe I'll put a marker in the video, but if you're comfortable with Rainbow and JavaScript, or maybe Max and JavaScript, this is kind of where I would jump in and be like, all right, this is where we're doing stuff specific to Rainbow, specific to Max, and kind of in the flow of sort of what developing a web application with dynamic audio using Rainbow, this is kind of the cycle that you would get into. So let's go back to Max and let's see if we can add a little bit of dynamic to our synthesizer. let's add a little bit of tremolo, some amplitude modulation, the kind of thing that we looked at in the previous class. So right now, whenever I press a note, that note just plays with a static, fixed, no articulation or modulation on the amplitude whatsoever. So what I'm going to do is just multiply the output of this whole thing, maybe before the envelope. Yes, before the envelope. I'll just move this around a bit so it's not in the way. I'm going to multiply the output of this cycle by another cycle, and we can listen to the results, and you should hear a little bit now, a little bit of tremolo. Actually, you're hearing quite a lot of tremolo, but actually, we're actually doing ring modulation right now, not true amplitude modulation. And that's because this cycle is going from -1 up to 1 and not from 0 to 1. So I'm just going to scale this to be in the range using scale tilde instead of going from -1 to 1 to go in the range of 0 to 1. And now we should hear what sounds a bit more like a true amplitude modulation. There we go. Much closer to the tremolo I was expecting. And if we want to control this, we can, of course, use a param tremolo. And let's just do at min, doesn't really matter. Let's do at min 0 at max 10, say. And this will set we'll use this to set the speed of our tremolo effect. So I'm going to just connect this. And what you can do that's kind of cool here is using a scale. So imagine so this cycle, after it's been scaled here, it's going up and down between 0 and 1. And what I'm going to do is use the lower half of the output range to just kind of like bring the floor up on that. So as this tremolo value goes closer and closer to 10, it's going to be using more and more of the full range, that full 0 to 1 range of the output of this cycle. But as it goes closer and closer to 0, it's going to use less and less of that range until it's using none at all, and it's just outputting a 1. I'll show you what that looks like. I can do now scale 0, 10. So remember, at 0, I want no tremolo at all, so that'll be a 1. And at 10, I want the max tremolo, so that's going to be 0. This is the floor, like how whether the output of this scale is going between 0 and 1 or 1 and 1, which is to say just staying at 1 the whole time. So I'm going to connect this like so. And now we should be able to use, if I make an adder UI, we should be able to, I don't like how this has gotten all crisscrossed, but maybe it is what it is. No, we can just do this. So now there's a tremolo attribute, and if we start playing normally, let's set this to 0 and then play normally, and then set this to 10. And now we're getting full, beautiful tremolo. And you can see if I make another outlet here by doing out tilde 2, which generates another outlet that we can see here on this rainbow tilde. If I take a look at this, now we will see, it's adding them all together. So because this is at polyphony 10, there's actually 10 separate LFOs, and it's adding all of them together. So I need to divide by 10 here to properly visualize the result. But let's take a look at this. There it is. So what you should be able to see as I bring this tremolo down to 0 is it just flattens out. But then as I go up and up and up, it's using more and more of that range. I'm surprised to see that at 10, they must be a little bit out of phase or something. I actually don't totally understand why these values are what they, it must be that they're out of phase. If I look at the output of this here, yeah, so if you hover over patch chords in a polyphonic rainbow patcher like this, you can see, actually get a visualization of all those signals at the same time, which is kind of cool. If you look closely, you'll see that not all of these LFOs are right in phase, which is why when I divide by 10 here, I'm not getting between 0 and 1. I'm getting between some other number and some other number. That's not important. The important thing here is that when the tremolo is 0, there's no wiggle, and then as the tremolo kind of increases, you'll see we're using a bigger and bigger range. So I'm actually just going to get rid of this and also get rid of this out 2 here back in my rainbow patch, because we're done visualizing that. And I'm going to show you a neat trick here. So there's sort of 2 things that we could control here in the tremolo. One is the tremolo rate, so how fast is the signal wiggling up and down, and the other is the tremolo depth. And right now we're just controlling the tremolo depth, but what we can actually do is connect this here, and now we've made kind of a meta parameter to where this param tremolo is controlling both the rate of this LFO and also the depth. So you'll hear what that sounds like if I start to mess with this. So if I make this 0, no tremolo at all, say 2, just a hint, if I make it a 5, you can hear a little bit of warbling, and then at 10, both the rate and the depth are very high. So rather than having to control those 2 things separately, now I'm controlling them together, and it's kind of simplified the interface to dealing with this patch. So this is cool. We've got something we can control here. So now I'm going to save this and export it again. So I'm just going back to the export sidebar here, hitting export again, and it will put the same patch in the same place. And it takes a second because, again, it's sending this all up to the browser or up to the server and getting back compiled code, but gives me a chance to have some water, so that's good. I hope that swallowing sound isn't too loud. Okay, so with this, we've now exported a new version of this patch that has this param included here. And in fact, we could, if we wanted to, take a look at this export, and you'll see, in fact, here in the parameters, in this JSON description, that there is, in fact, a tremolo parameter defined. So that's kind of cool. But what this lets us do now is actually control that from within our patch, our sketch rather. And the way I'm going to do that is I'm going to set up a behavior that's kind of like this. Like when I click and then move the mouse to one side or the other, the further I move from where I clicked down initially, the bigger the tremolo is going to be. So in order to do that, I'm going to need a couple of variables here. Let's call it mouse down X and mouse down Y. So this is going to store where the mouse down actually is. And then in mouse pressed, I'll do mouse down X equals mouse X, the current position of the mouse, and mouse down Y equals mouse Y. And now what we can do in the draw function, which is called once per frame, we can use this mouse down X, mouse down Y to control our tremolo. So let's do that down here. Let's do it here. Let's do control tremolo. We'll do if mouse is pressed. Then let's figure out what we want to set the tremolo to. So we'll do something like let's do delta X equals that's perfect, mouse X minus mouse down X. And let's also do math.abs, so it's the absolute value of that. So whether we go left or right, it's going to be the same thing. Let's do let delta X normalized. So instead of, I'm going to divide this by the width of the the sketch so that it's going to be in the range of 0 to 1 rather than 0 to whatever the width of our P5 sketch is. I can see that Google Copilot is helpfully suggesting using the map function again. However, it's saying to map to the full width, which is not what we want because we actually probably want it to be only half of that, I would say. So I'll do equals map delta x 0 width over 2 0 1. But this again takes this value in the range 0 up to the width of the frame and gives us this in the same thing, but in the range 0 to 1. And then finally, we can do let tremolo equals device. So this is the rainbow device dot parameters by ID dot get tremolo. And finally, tremolo dot normalized value equals delta x normalized. So before we listen to this, a quick word just to say that if you go to Rainbow, if you want to learn more about all this kind of stuff, you can always go to rainbow.cycling74.com, click on Learn, and then a lot of the stuff we're dealing with here, if you scroll down, will be down under Working with JavaScript. And there's details here on sending Midi, starting the audio context, loading Rainbow devices. Right now we're dealing with getting and setting parameters, and there's some example code here that shows you how to get the names of all the parameters, how to fetch a particular parameter, which is what we're doing here, and then setting its value, either the absolute value or the normalized value. So right now I'm setting this tremolo value, and in fact, if I come back to my browser now and do a hard reload, so you can definitely hear the tremolo, but you probably also hear a little bit of zipper noise, like we talked about in our last class. And as you remember, zipper noise usually happens, or I think almost always happens, when you're trying to update something at audio, or you're updating some audio rate signal using something that's not coming at audio rate. And if we look in our Rainbow patch, we can see exactly what's happening. There's this param tremolo that's directly controlling both the frequency and the scale of this oscillator. So to fix that, I'm just going to chuck in a line object, just like we did in the last class. I'm going to give it an initial value of 0 and a ramp time of 40. And there's something kind of neat. This, I think, Rainbow's being actively worked on and is changing a little bit. But in Rainbow, we don't have to construct messages for this line object the same way we do in Max. Instead, there's this cool attribute called keepRamp. And if I set keepRamp to 1, that means that as this line object gets messages in, it'll use this default ramp of 40 no matter what number is applied to it. And this is actually a really convenient way to sort of smooth out audio signals. And annoyingly, or just it's the way it is, Rainbow and Max are not always one-to-one. This keep ramp attribute, I don't think it exists in vanilla Max. It's Rainbow only, but it's definitely convenient here, and we can use it to smooth out this signal. So I'm going to now connect this like so. Connect this like so. This won't actually connect this audio signal to scale because this is a message rate scale object. But if I make it a scale tilde, now it should connect normally. And this should be smoothed out. And what I'm going to do is export this again now that we fixed it. And while that's waiting, we're all waiting for that, we can come back and just take a look at this. So this lets us control that tremolo using a param like this, and we've built our own tremolo here, kind of using our knowledge of what works in Max. So using this kind of amplitude modulation technique that we looked at in the last class. Okay, let's try now reloading. Sweet, we can hear that tremolo going in both directions. So, you know, I feel like I don't want to give the impression that when you want to do anything in Max, be it add a tremolo, or as we'll look at in later classes, add effects, distortion, reverb, phaser, whatever it might be, you don't have to build all this stuff from scratch. There's a lot of not only great examples online that you can use, but also in the particular case of adding effects to Rainbow, there is an amazing library of kind of off-the-shelf effects in this package called the Rainbow Guitar Pedals. Now, we haven't looked at Max packages at all yet, but the important takeaway is that these are, in the same way as at the beginning of the class we were looking at abstractions and subpatchers, many packages are just bundles of abstractions or abstraction-like things that somebody has made and is offered up to the community that we can take advantage of. You can find the package manager by going to File, Show Package Manager, and then once you're here, searching for guitar pedals. And these, the Rainbow Guitar Pedals, I can see that there's some kind of nonsense going on with my package, so I don't know what's up with that. But what I'm going to do actually is go and delete. Sometimes mine gets in a funny state, so I'm going to go to Max 9, Packages, Rainbow Guitar Pedals, just delete this, and maybe I'll just delete all this as well. And then Documents, Max 9. Packages, is there guitar pedals in here? Yeah, maybe this is the issue. Whatever Rainbow Pedals is, we don't need that. Maybe that was the issue. If I go to Packages, maybe this is the problem. Okay, so let's try. I guess this is good because you can see me install. I'm going to make sure I've saved, by the way. And then I'm going to go back to the package manager and search again for guitar pedals. And now, okay, so it's now thinking correctly. I don't have it installed anymore. I'm going to hit install. And now it will install this guitar pedal package. And all it's doing is pulling down this kind of library of effects built in Rainbow. Stuff like I was talking about before, echo, delay, reverb, glitch effects, distortion, and we're going to be using the distortion here, an overdrive kind of effect once this finishes downloading. But there's a bunch of other packages that are worth checking out as well. It's definitely something to explore. There's packages that do everything from low-level kind of synthesis of various waveforms all the way to making bringing some computer vision algorithms, audio analysis and music information retrieval, visual generation. One of my favorite packages, vSynth, is a really cool one for generating visuals. Anyway, the package is installed. And if I go to Extras, Rainbow Guitar Pedals, we can see some of these pedals that Manuel has made. And we're going to be using the one in Overdrive. So if, having brought up this launcher, if I now click Overdrive, this will launch the Overdrive demo patch. And I'm just going to turn down the volume a little bit and start playing this. You'll be able to hear what it does. So now I'm just going to start adding some distortion by cranking up this drive attribute. And you're free to just take this. If you double click and look inside, there's actually a lot of really helpful documentation here of how to do all this stuff and how the pedal works. It's really, really well documented in general. We can just grab this. I wish we could just take this Rainbow patch, copy it, and paste it into our Rainbow patch. Unfortunately, it won't work. And it's only a naming thing. It's because in Max patch, Rainbow tilde is the name of the Rainbow tilde patch. In within Rainbow, you make subpatchers by doing P, just like in Max, and then putting your subpatcher contents in there. So it's a little bit, takes a little getting used to, but what you can actually do is if you want to copy the contents of a Rainbow tilde patch into another Rainbow tilde patch, you can just come into this Rainbow subpatcher, unlock it, select everything, copy it, and then here in our patch, I'll make a new subpatcher called overdrive, if I can spell it, and then just paste this in here. So I just pasted in the whole thing, and that's just the objects within that Rainbow patcher from the overdrive example. And now you see it's got those inlets and outlets, and I can just take this and snap it in place right after my tremolo. An interesting kind of thing to play around with actually could be, is there a difference when you plug it into the input versus the output? Maybe there's a different effect, or a different, maybe it sounds different when the tremolo comes before or after the overdrive. Something to experiment with. And, you know, going back to look at all the pedals that you have access to, there's a ton of stuff here. And one thing to play around with too is, what does it sound like when you stack these effects on top of each other? Is it different if you put one before the other or one after the other? There's a lot of possibility to explore there, especially considering how many different effects are here. But in any case, now we've got this overdrive, and back in our max patch, that should add some more attributes or some more parameters for us to play around with. And now if I hit this adder UI, you'll see, in fact, we got a whole bunch, because the overdrive, if we look in it, there's a few parameters defined here, both for some kind of filtering and shaping, but also maybe the drive parameter. That's the one we're maybe most interested in. They do have this kind of interesting prefix, poly overdrive. It's just because these parameters are not defined kind of in the root of this Rainbow patcher, but rather within this subpatcher. Rainbow tries to help us out by giving them this prefix. So instead of just being called drive, it's called poly/overdrive/drive. And of course, that's important because in this patch, if we had a parameter called drive, they would want to have the same name and there might be a conflict. But the important thing is I can come here and click this drive attribute, and now you can hear that this has a little bit of overdrive to it. And if I crank this up to 100, the maximum value, you can really hear it starting to lose that pure sinusoid tonal quality and become really sounding a lot more like a square wave, which is ultimately what overdrive will drive a sinusoid signal to. So cool, we've got another parameter to play with here, and I'm just going to save this and export this one more time because it gives us something else that we can experiment with. And since we've already used the tremolo on the on the X coordinate, it seems natural, easy, that we can use the Y coordinate to control the distortion. So while this is compiling, I'm just going to jump right back to VS Code here. And under where we have control tremolo, I can do control drive. And we'll do same thing as before. If mouse is pressed, we'll do, and this is going to look really, really similar. We'll do, yeah, and it looks so similar that Google Copilot or GitHub Copilot or whatever it is able to guess, I think, basically everything that I'm going to want to do here, except it doesn't know about the name of the parameter, but we'll get there. So I'll do let delta y equal math.abs mouse y minus mouse down y, and then let delta, yeah, and that's exactly right. Same as the delta x normalized, except we're working with the height this time, and delta y. And now we'll do let drive equal device dot parameters by id dot get. And now we have to be careful here. The name of the parameter is not drive. Going back to max, we can see the name of the parameter is actually poly/overdrive/drive. That's the parameter we want. So in here we'll do poly/overdrive/drive. And last but not least, we'll do drive.normalized value equals delta y normalized. So now tremolo is on the x coordinate, drive is on the y coordinate. If I save this, let me pop back to max. Cool, looks like our patch exported successfully. And if I reload this, we should have tremolo on the x and drive on the y. one thing that I notice that might be something we want to mess with is the drive is happening so fast. Maybe it's fine. We could always tweak that later. But for now, we've got what we want. We've got these parameters mapped, and that's, that's cool. So one thing that I want to, there's one more thing I kind of like to add here. And that's, I think it would be nice if we had some, we've got this great tremolo thing going on. It'd be really nice if we could see that, right? If we had some indication that was happening in this patch. And the same goes for the drive, actually. And maybe let's start with the drive, because I think that is easier. As we know, as this kind of, as we increase the drive more and more and more, we go from a sine wave to a square wave. So why not make our shape go from a circle to a square? Well, that's pretty easy. Instead of drawing an ellipse down here, we'll just draw a rectangle, and we can make it more or less rounded depending on the value of the drive parameter. So what we can do is we'll just do, instead of ellipse, we'll call rect, passing, not reflect, but rect, passing the same parameters. Actually, rect mode center. We'll deal with that in a second, but we'll do rect and then mouse X, mouse Y. And now we want to do the width, so that'll just be radius and radius. And now we're in an interesting spot because the question is how rounded off do we want the corners? And basically, the closer the drive is to being full, the less rounding that we want. And the closer that the drive is to being we want no rounding when drive is full and full rounding when drive is 0. So what I'm going to do actually is make another parameter here. We'll just do let let corner radius equal 0. No, we'll let corner radius equal radius over 2. That's the maximum. So this is a fully rounded rectangle. And then down here where we control the drive, we'll just do corner radius equals map. Oh, dude, the Copilot, it's so good. We'll do corner radius equals drive.normalized value. And as that goes from 0 to 1, we go from, so at 0, the drive is totally down, and we want the corner radius to actually be its full value, which is going to be radius over 2. But then when the drive is at its maximum value, we don't want any rounding on our corners at all. So I'll just set it to 0. So this is the magic here that's changing the radius of our rounded rectangle to, instead of being radius over 2, which is full rounding and essentially turns our rectangle into a square, or sorry, into a circle. This lets us gradually scale that down to being a full square as the overdrive gets more and more. So now I just got to plug corner radius down here, and we should, instead of drawing an ellipse, be able to see that reflected here in our sketch. You can see our little square is becoming more like a... You can see our circle becoming more like a square. Something I noticed that's messing me up a little bit is it's offset. It's the rectangle is drawing from the corner. We can fix that pretty easily by up here in setup just doing rect mode center. And now that's a bit more of the behavior that I was hoping for. Okay, last thing that I wanted to be sure to cover is This is cool if we're setting values in Max, but something that is often really, really handy is, can we read values back from Rainbow? Maybe we're like computing something in Rainbow that we want to control, and then we want to use that to reflect something happening in our drawing. So jumping back to Max, there's one more thing that we can play around with here, and that's getting values out of the synthesizer. In particular, I'm interested in getting out this value here, the value of our LFO at a given point in time. So what I'm going to do is take the output of this thing, and I'm going to use this to get... I'm going to use this to get... Oh, sorry, I just had a thought about something that... I just had a thought. Doesn't matter. Ignore my thought. So I'm going to take the value of this LFO and just turn that into something that we can work with by turning that into a message. So we've looked at getting params, MIDI, and audio in and out of Rainbow devices, but now we're going to talk about messages. So when I make something like an out here, this generates a message outlet. And you'll see back in Max that there is another outlet here. And if I connect, say, a floating point box here, we can see, or maybe let's not do that. Let's make a message box so we can see what comes out here. But if I take the output of the scale now, and an object we haven't looked at yet, I don't think, maybe we looked at it, I don't remember, is this snapshot object. And what snapshot does is it converts audio signals back to regular messages. So it kind of polls frequently this audio. So at some frequency, in this case, every 16 milliseconds, it looks at this audio signal and just grabs a number, whatever the number happened to be. And if I hit these notes, sorry, if I turn the tremolo down, the tremolo up rather, you'll start to see these values swinging around between 0 and 1. One thing that's a little bit subtle that we have to be aware of here is because this out tilde is actually sending values from every single one. Because this is polyphonic, this rainbow patch actually contains 10 subpatches. And so we're actually seeing not just one number coming out here, but like sort of bursts of 10, one for each one of these voices coming out. We don't necessarily want to work with all of them. We only want to work with one. So what I'm going to do is a little bit of massaging here in the rainbow patch to filter out just, say, the first voice. And the thought I was having before is maybe we don't want to necessarily look at the first voice, but I think it's a little bit too complicated to kind of look at some other ways we might handle this. So for now, I'm just going to say, you know what? I only care about voice number 1. All the other voices are irrelevant to me. So to do that, I'm going to use this object called voice, whose first outlet will report the voice index of this particular patcher. So if I was looking at voice 1, the output of this outlet would be 1. If I was looking at voice 2, the output would be 2, etc., going all the way up to voice 10. And all I'm going to do is throw in a gate here and an equals equals 1. And this is just saying, okay, only open this gate for voice number 1. All the other voices aren't going to send any output. Just voice 1 is going to send some output. And this is just going to clean up and thin out a little bit the signal coming out of this message outlet. So you won't actually see any change back out in the max patch. We should still hopefully see this number going up and down. We don't, because voice doesn't actually send a value here right away. Oh no, it's because I put this in the wrong place. This should actually be here. And now will we see values coming out? We don't. I don't know why exactly that is, but in a situation like this, where I think part of the problem is that one of these objects has gotten into a weird state, something you can always do with Max is just like select an object that you think is, if you have an object that you think has gotten into a weird state and you want to just like reset it back to how it was when it first got made, you can always just select that object, and that includes subpatches and abstractions. You can select the whole thing, delete it, and then just hit Command Z, just undo deleting it. And as soon as this patch loads up again, which it's not doing, How come? What has gone wrong? I don't even see it. It's just not doing it. It doesn't seem to be doing it, which is pretty annoying. I think Max has encountered some kind of terrible... I don't know what's happened here, but it's not good. So I'm just going to restart Max. This kind of thing can happen, you know? It's computer music, we're working with computers, they're volatile, they're emotional, they're always having these outbursts. They're not like humans, rational, simple. Okay, so maybe it's something to do with Max 861 being available. Who knows? So what I'm gonna do now is turn audio on. I'm missing something. Voice equals 1 into gate, into output, into snapshot. That's going through normally as we'd expect. There's the signal. Snapshot should be snapshotting into gate, into out equals 1. This all looks right to me. Maybe the issue is this voice. I think voice needs to get a bang in order to do its thing. So what I'm going to do is make a... this has gotten... it's exactly what I wanted to avoid, but here we are. Maybe I'll move this down. TBF. So what I will do is this snapshot, I'm also going to make it bang on this voice to report. I think voice needs to be banged, so maybe this will do it. Yeah, there we go. Okay. So now we're actually getting, so sorry about that little interlude. Again, this machinery, maybe not totally necessary, but it's just there to thin out all the messages coming from every voice and just get the one voice that we care about. Important thing is, now we have messages coming out of this second outlet, and we can actually hook into those on the JavaScript side. So I'm going to save this one more time and then export this using web export. The path looks correct, the file name looks correct. I'm going to export it again. And now I will hop back over to here. So what we can do with this that's handy is we can hook into, after loading Rainbow, we can also start to listen to messages coming out of the Rainbow device. So what I can do after after the device has been created, but before logging the result, we can add the following code that will connect the device, or rather call a function every time the device updates or sends a message. So we can do device dot, I actually forget the syntax for this, so I'm going to go to the documentation, the Rainbow documentation, and come down to sending and receiving messages. And down here is a code snippet that shows what I need to do. I need to subscribe to message events from the device. So I can do device.messageEvent.subscribe, and this will be a Google Copilot, GitHub Copilot, Microsoft Copilot. Copilot is trying to make me use big arrow syntax, so maybe I will do that. But I'm going to call my variable event and not message. But down here in the body of this function, I'm actually able to figure out what Rainbow is trying to tell me. So events, as you can see here, have two parts. They have a tag and a payload. The tag for outlets will always be which outlet. So in our case, because it's outlet 2, the tag will be out2. So what I can do is if event.tag equals out2, and then process the payload somehow. So in this case, what I'm going to do is make a new variable up here called let current tremolo value. It's not really the value of the tremolo, it's the value of the LFO. So I guess I'll call this current LFO value and set this to 1 by default. And down here, I will just do current LFO value equals not event.data, but event.payload. And that should be all we need to connect to message events coming from this Rainbow object. Now all we have to do is down here in our code actually use this current LFO value somehow. And I think all we need to do is create a local version of this radius object. Or what's the best way to do this? I guess what we do is under corner radius, or rather above corner radius, we do let scaled radius equal radius times current LFO value. Yeah, there we go. And then everywhere where we use radius, so corner radius, everywhere where we use radius down here, we should instead use scaled radius. So that's here where we set the corner radius, here where we set the corner radius again, and then down here, I should set both of these to scaled radius. And scaled radius. And now I believe that should control the kind of, that should scale the radius of our little square up and down as we move left and right. So let's take a look at this. Fun. Okay, so that's the big part of what I wanted to show you was just how to. So there's how to send MIDI events to an exported Rainbow. Here is how to load a Rainbow device in your browser, how to send MIDI events to it, how to set its params, and also how to read values back from your Rainbow device using a combination of snapshot and listening for message events. If we were in the room right now, what I would tell you is to build on this. Obviously, this is far from the coolest, most exciting P5 sketch out there. In fact, it's kind of garbage. But I would say, here's a starting point. Can you make more interesting design than this? Can you do more interesting sound design than this? In particular, as we looked at with this, with these guitar pedals, actually the place to do this is to go into extras and then down to Rainbow guitar pedals. We only looked at one, the overdrive. And there's a whole ton of other things here to play with on top of what we already looked at last week in terms of how to do synthesis using ADSRs, FM synthesis, different oscillators, filters. There's a lot of material here to play with. So one thing I would suggest you could try on your own is, can you build on this using other guitar pedals? Another thing you could try that I think is fun is to use use filters to kind of try to make I'm trying to sorry, I got a little anyway, point is that another thing you could try in addition to using the pedals would be to play around with formants. We haven't really talked about formants in class, or rather at any point, but the basic idea is we did look a little bit, or we have talked previously about the shape of a sound. So how you can hold, for example, like a given pitch, like and then change the shape. And when you're moving to different vowels, what you're doing is changing the resonant structure of your mouth. And of course, this emphasizes certain frequencies and cuts out others. But of course, that's exactly what a filter does. So another thing that you might do in a lab kind of context would be to say, okay, can I make a rainbow patch that lets me synthesize different vowels by changing the position of a couple of filters? You can actually go online and find what the cutoff and sort of slope values are for different vowels, roughly, and then build those into your patch. So those are kind of two lab exercises that might be fun to experiment with. Last thing I want to show you is kind of where you could take this sort of thing. I mean, this is like as you'll see pretty soon, I'm not exactly not particularly gifted when it comes to P5 or the sound design aspect of this. But if I go to class 4 www npx and start my own. So this is something I was poking at before class. Go to localhost 8081. This is the same thing we were looking at already, except little visualization. That just connects where you mouse down. With a tiny bit of physics, a little fake physics, that just makes it, I don't know, something you could play around with. So I think that's basically all I wanted to show. Thank you for being here for this snow day class, and yeah, look forward to hanging out next week and talking about some more stuff.